Numpy offers a variety of functions for manipulating arrays, allowing you to reshape, join, split, and modify data efficiently. Mastering these data manipulation techniques is essential for data analysis, machine learning, and scientific computing. As always, before we get started, we need to import our NumPy library, so we'll go ahead and do import NumPy as np. Let's start off by trying to understand how arrays are shaped. The shape of an array is a tuple that gives you the size of the array in each dimension. So let's start off by creating a simple two-dimensional array. We're going to call our array array2d, and we are going to use np.array, and we're going to provide two lists here, 1, 2, 3. And for the second list, 4, 5, 6. And if we want to take a look at the shape of our array, we just do array2d.shape. And as we can see, we have a 2 by 3 dimensional array. So it's 2 rows and 3 columns. Now we can use the reshape function, which allows you to change the shape of an array without changing its data. To do this, let's create a new array and let's make it one-dimensional. And we're going to auto-generate this using the arrange function, and we'll just provide 6 values. And when we take a look at our 1D array, we have this one dimension. Now, if we want to change the shape of this array and make it a, let's say, 2 by 3 dimension, then we would use the reshape function. And so we would do array1d.reshape, and then we provide the dimensions. So it's going to be 2 rows and 3 columns. And when we do that, this has been restructured and reshaped to the 2 by 3 now dimensional array. Once we created a 2-dimensional array, we can convert that back into a 1-dimensional array based on 2 different types of functions. This method of converting it back into a 1-dimensional array is considered flattening. The first method that we could use is the flatten function, which returns a copy of the array collapsed into 1 dimension. So let's save this as a variable called array reshaped. And we take a look at array reshaped. And now if we want to convert this back into a 1-dimensional array, we would do array reshaped.flatten. And this converts this back into a 1-dimensional array. The second way that we could flatten an array is we could use the Ravel function, which returns a view, if possible, of the array collapsed into 1 dimension. So to do that, all we have to do is just change flatten to Ravel. And it also returns a 1-dimensional array. Now note that use flatten when you need a copy of the array, and use Ravel when you need a view, which is basically more memory efficient. We can also transpose an array, which swaps its dimensions. So instead, we could switch this to transpose. And when we run this, it becomes a 3 by 2 instead of a 2 by 3. Alternatively, you could use a .t attribute, and it will also transpose the array. Joining or combining arrays allows you to merge multiple arrays into one. The concatenate function joins a sequence of arrays along an existing axis. Let's create some new arrays. So let's say array A, and that equals to np.array. And here we'll provide 2 lists. So the first list is going to be 1 and 2, and the second one is going to be 3 and 4. Then we'll add array B, and with np.array, and here we're going to provide 1 list, and that's going to be 5 and 6. And when we run that, okay. Now to concatenate these two arrays, we're going to use the Numpy library np.concatenate. And here we are going to provide a tuple of the two arrays that we want to combine, which is going to be array A and array B. And here we're going to provide along which axis we want this to be added. So we're going to add axis 0, which is basically going to add another row. And when we run this, we have our combined array now. So we took this array, which has two rows, and we added one more row, which was this array. Now, there are a couple ways that we could stack arrays. The first one is a vstack. And to do that, we would use, again, the NumPy library, and then we will use vstack. And this will, of course, stack the arrays vertically, so row-wise. And here we will just have to provide a tuple of the arrays, again, so array A and array B. And we do that, and similarly like we did before, we have this stacked vertically. If we want to stack them column-wise, we would use the hstack method. And to do that, we will add one more array called array C. And we're going to create that using the np array. And here we're just going to provide two dimensions, but by one element. So we're going to have 7 and we're going to have 8. Now, if we want to stack this horizontally with the first array, which was array 8, then we would do hstack, and again our tuple, and then we will use array A, and then we'll stack that with array C. And when we run that, we've added on a column, an additional column to the first row and the second row. Now, why is this important? See, if we try to do this with our previous array, which was array B, and if we just change this from B to H, and then when we run this, then we get this error. And what's important here is that when we're stacking and combining these arrays, we have to remember that the dimensions have to be exactly the same. So when stacking arrays, we have to always remember that the dimension or the side that we want to stack or add onto has to be the same size. So with this example here with our array, we have 3 columns and 2 rows. So if we, as we just did right now, we added on 2 values on the right side, so it has to have the same dimensions to be able to place an element here as well as here. If we only try to have only 8 or only 7, and we only wanted to add one element here, but we didn't have an element to add here, then of course we would get the same error as well, that the dimensions do not match. So it's important that these dimensions have to match exactly to be able to successfully add on to these arrays. So we've added on to the rows and we've added on to the columns, but we could also add on to the third dimension, which is the depth. So to do this, we would use the np.stack. So instead of on the top or the bottom of the array, and instead of on the left or on the right side, we want to place an array behind this array, so the depth dimension. And to do that, we could just do array A, and we will stack that with array A as well. And when we do that, we have basically 2 arrays stacked depth-wise. So it's 1, 2, 3, 4, and 1, 2, 3, 4. We can use stack to stack arrays along a new axis. So instead of doing dstack, we could just do stack, and we could specify the axis that we want to stack on. So let's say axis equals 0, and we get a slightly different array stacked. Splitting arrays allows you to divide an array into multiple sub-arrays. Let's go back to our first array, which was the one-dimensional array. And let's say that we want to now split it into 3 equal-sized subarrays. To do that, we would do np.split, then provide the 1D array, and then we provide how many equal parts we want to split, so that's 3. And when we do that, we have 3 arrays equally split. You can split an array horizontally, meaning column-wise. So let's go back to our 2D array. And now let's say we want to split this into 3 equal columns. So again, we would do np.hsplit this time. And we provide array 2D, and we want 3 equal parts, and that gives us 3 columns. If we want to split an array vertically or row-wise, we would use vsplit. So np.vsplit, and then array 2D. And since in our original array we have 2 rows, we could split that into 2. And we have 2 separate arrays now. We can also split an array along the depth or the third axis. So let's create our 3D array. So array 3D, and that is going to be, let's reuse our stack method, array A, and array A again. And we're going to provide the axis is equal to 0. And we take a look at our array 3D.shape. We have a 3-dimensional array. And if we want to split this along the depth axis, then we would do np.dsplit and then array 3D. And how many even parts we want? We want 2. And there we go. We have 2 evenly split arrays along the depth axis. Numpy provides functions to insert, append, and delete elements in an array. So let's take a look at our one-dimensional array again. And let's say we want to insert. The insert function allows you to insert values into an array at specified indices. So let's say we want to insert the value 99 at index 2. And we would do that using the np library insert. And we select the array that we want. The index position, so it'll be index number 2, and the value, which is going to be 99. And when we do that, we added that value into the second index position. The append function adds values to the end of an array. So if we want to add the 99 value at the end, we would just do append, and we'll just delete this, and we would append 99 to the end of the array, and there we go. The delete function removes elements at specific indices. So if we wanted to remove the first element in our array, we would use the delete function, and then we would specify the position. Well, if we wanted to be the 0, there will be the 0 index, and we removed that 0. Understanding how copying works in NumPy is important to avoid unintended side effects. Assigning an array to a new variable does not create a copy. Both variables point to the same data. So if we were to take our 1D array and let's say new array, and we assign that from array 1D, and we take a look at new array, of course we have our original array here. But now if we wanted to modify new array, let's say we want to change the first index to 99. So it will be new array, and the first index equals 99. and we take a look at our new array, then we have our 99 here. But if we also take a look at our original array, which is array 1D, we see that it has been modified as well. So this does not create an exact copy of that array. It just points to the same data. So whatever changes that we apply to this new array will also apply to the original array as well. A view creates a new array object that looks at the same data as well. So instead of assigning it just like this, we could do dot view, and of course it assigned our original array, which was what we've changed before. But if we again change something in the new array, then we also see the changes in the 1D array as well. So the changes to the data in the view will affect the original array as well. Now, using copy creates a new array and copies the data. So we would do, instead of view, we could do copy. And when we run that, we have our array. And now when we try to change it to, let's say, 29, then it shouldn't change anything at all in our original array. Broadcasting allows NumPy to perform operations on arrays of different shapes. So let's create two new arrays. Let's say array I, and that equals to np.array, and we'll have a dimension of 1, but with 3 elements. And let's say we want an array j, and we're going to have np.array, and we're going to have 3 separate elements here. Let's say 4, 5, and 6. And let's take a look at array I.shape and array j.shape. Now we could broadcast these two. So let's say we want to now add array j and array I together. We could do this without any problems. When we do array I plus array j, it added these two together even though they weren't exactly the same. So what basically happened was 4 was added to these 3 values, and 5 was added to these 3 values, then 6 was added to these 3 values, and we got this new array. Sorting arrays is a common operation in data analysis. The sort function returns a sorted copy of an array. So let's create a new array called array sort, and we're create a very simple array with a list of 3, 1, 2. And now if we want to sort this array, we would just do np.sort and array sort, and there we go. Our array has been sorted. We could use the argsort function, which returns the indices that would sort an array. So instead of using sort, we would do argsort. This returns a list of indices after it has been sorted. So we can see that the 3 should be in the 3rd position. So since this is index 0, in our original array, this has been moved to the end, and then this was index 1 and this was index 2, so they've been moved forward here. So this is the new array that has been sorted, but instead of giving the values, it provides the indexes after it has been sorted. And now this can come in handy because we could use these indices in the newly sorted way, and we could try to then sort another array based on these indices. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.